infinite limits are things we've already looked at. We just maybe haven't called them infinite limits. Okay? So what I want you to do right now is I want you to go ahead and graph the following equation. F of x equals 3 over x minus 2. Okay, so I want you to graph f of x equals 3 over x minus 2. Some video.
When I watched the video from the suit last week, you could hear classmates that's
Okay, so I want you to go ahead and graph 3 over x minus 2, and then I want you to come up, okay, with answers to those questions. What? How do you know that? Did you graph it already?
Yeah.
Oh, I thought you were doing that in your head, and that's why I was like, how did you know? Okay, so we have negative infinity and positive infinity. But do you remember what I told you about those when we were looking at tables and graphs in the very first section of limits?
That does not exist.
These do not exist. Okay, so really what I want you to understand is that these really do not exist, but I want you to go ahead and answer them as positive or negative infinity. But just understand that just because you're giving them an answer here doesn't mean they technically have a limit. What this is right here, this is a description. Okay? This is not necessarily the answer. This is describing and telling you they go to negative infinity and positive infinity. Okay? And so then that's pretty much it with the infinite limits. Okay, so you're going to be doing positive infinity, negative infinity. Now, real quick, if I asked you this question then in response to that, what would my answer be? This one would be DNE. Because why?
There's
Let's think about that. How did we find limits on graphs? What did we do? Follow the line.
Oh, it's not the same on equal sides.
It's not the same on equal sides. Okay, the reason here why this is a DNE is because this is negative infinity and this is positive infinity. The limit from the left does not equal your limit from your right. Now, if this would have been negative infinity right here, your answer would have been negative infinity. So, in order for you to have an answer there, your limit from your left has to equal your limit from your right. Okay, are we clear on that? All right, so let's talk a little bit about vertical asymptotes. Okay, vertical asymptotes. Vertical asymptotes occur, does anybody know? Okay. Occur where my denominator equals 0. So, find the vertical asymptotes. Find the asymptote. Okay. Okay, so let's do this without graphing. Let's do this algebraically. Notice what it says, denominator equals 0. This is all you have to do. All you have to do is solve. So I know that x minus 1 equals 0 when I divide by 3. What does x equal? There's your vertical asymptote. That's it. If you graph it, it'll confirm that. Okay, now this one on the other hand, what do you notice about x squared minus 1?
X plus 1, x minus
It can be x plus 1, x minus 1. So essentially, what happens to your x plus 1s? They cancel. So as a result, x plus 1 has a removable discontinuity, has a hole in the graph, and your only vertical asymptote will be here. So x equals 1 will be your vertical asymptote. And if you graph it once again, that would confirm. At negative 1, you'll have a hole in the graph.
It's easier to graph it.
It might be, but I mean, we got it done faster by the time that you would have entered it in and graphed it.
It's easier.
Okay. Alrighty, any questions over the vertical asymptotes? Okay, this is what I need you to do then. Alright, and once again, since there's not as much information, you got to make sure that you know what we're doing. Okay, I need you to do, first of all, 1 through 4. And then I need you to do 9 through 15. And then I need you to do 29 and 30. Actually, 29 through 31. Take that back. And then, let's go with 33 through 42. Yeah, that'll be good. You guys can get a good start on it. 33 through 42. Okay? All right, so that is your assignment.